All right, welcome everybody. We're here today with a very interesting company. We heard about this company, Modvion, from one of our viewers in Sweden who visited one of their towers. And so we're lucky today to have with us Geir Soderin, who is a development engineer, and Otto Lundman, who is the CEO of Modvion. So thank you guys for joining us today.
Thank you.
Thank you.
So you build wooden towers for wind turbines. What is the current technology for building a wind turbine?
So the current technology for building the towers are tubular steel towers mostly. But as wind power becomes more cost effective, the taller you make the turbines, these cylinders that make up the towers, they need to become larger than what is possible to do really with that technology, since it needs to be transportable.
Now, wait a minute. I mean, steel seems like the perfect choice here, right? It's pretty cheap. It's very strong. Why can't we just keep going taller and taller with steel?
Yeah, so logistically, you need a larger base diameter than the 4.5 meters that is possible to transport on the average road. So you need a modular technology, and Modvion has such a technology. But then by going away from steel to a wood-based material, as we do, we lower the weight, we lower the production cost, we make it a whole lot more carbon neutral. Instead of a large emission, we have carbon sequestration in the material.
Wait a minute. So explain to our viewers how wood can be carbon neutral. It seems kind of counterproductive, right? Because you have to cut down trees and everyone loves trees. So why is it carbon neutral?
In general, in Sweden and many parts of the developed world, the timber industry is actually, they're growing trees to cut them down and then they regrow them again. So it's not like they harvest rainforest in general. It's more of a developed industry with lots of history, and it's a sustainable system, and every time the trees grow up again, they capture more carbon from the atmosphere. So if you keep the wood in a structure as a wind turbine tower, it actually has a net negative emission effect.
So it's actually that the carbon is holding up the wind turbine, as opposed to it being either burned and going back into the atmosphere, or decomposing and going back into the atmosphere that way. So whenever you build a structure, whether it's a wind turbine or a house or a tree house or even like a table, you're sequestering that carbon, you're preventing it from going back into the atmosphere. And it's only when you finally either burn it or it decomposes that it would turn back into carbon in the atmosphere.
And by that point, it will actually be sort of back to neutral. So until then, it's actually a negative effect, or like. So that's,
Counting on that there's other trees growing up at the same time and sequestering carbon again.
Yeah.
Now, you brought up an interesting point. You said that current technology means that the base of the tower would have to get bigger than 4.5 meters. Why is 4.5 meters such a big deal?
Because that is the limit for what is transportable on a normal road. Whenever you get to a bridge or a tunnel, 4.5 meters is what is possible to get through.
So how does your system work? It's modular, but can you explain what that means?
So the modules are produced in a factory, and they have a shape, something like this, from the factory. I don't know if you see this well. And they are stacked on a truck. Either it can be stacked a number on each trailer, or it depends on the size and the weight capacity of the trailer and these kinds of things. But then you transport them like this, and then on the site where the tower is supposed to stand, you take the modules and you assemble them into sections, so circular sections. And this can be done sort of beforehand, and when the big crane arrives for erecting the actual tower, then the sections which are circular then can be lifted on top of each other, and then you put the turbine on top of that.
But now, why do we have to go up so high? Why don't we just build a lot more of them?
Well, by increasing the height, you get to the stronger and more stable winds, and you can put up a larger rotor and a larger generator. And since it's the area of a circle, the larger rotor means that you have so much more swept area, and therefore you can have a much larger generator and the cost per kilowatt hour goes down drastically.
So it's funny because when you think of like going bigger, a lot of times you think of finding stronger materials, and typically wood isn't considered to be like a very strong material because it just seems kind of common. You know, we built a chair out of it. We built our house might be built out of it. And you might be saying, but the big stuff, the skyscrapers, they're all made out of steel. So is that true? Is steel stronger than wood, or is wood stronger than steel?
Well, so steel is very strong per volume. So if you have a lack of space and you need a lot of strength, then perhaps a metal, perhaps titanium, very strong per volume. But if you need high specific strength per weight, then wood might be a good option.
Yeah, and thereby, when you build really large stuff, it can, in some circumstances, like for wind turbines, become more and more important with the specific strength. So
this kind of gets into the square cubed law of when you want to make something really big. Like, for example, there were a lot of articles that came out, like when some of the Godzilla movies came out, and it's like, Godzilla, because he's so big and massive, his bones would need to be so big to support himself that it just wouldn't look like Godzilla anymore. It'd just be this big 2 legs with a little, dinky thing on top. And so that's where the specific weight comes in, because when you're building really, really tall, you're adding stuff on top of itself. And so the heavier that stuff is, the more it needs to support itself. And therefore you need to add more, and then it's more and more and more until you have a really, really strong, big, beefy, a ton of material structure. Whereas if you just went for a lighter weight design, a lighter weight material, you might not need to do that necessarily.
And that's the first time I've heard the Godzilla reference, but I'll keep it in mind. Yeah, pretty much like that. You get a bad design spiral if you keep using a heavy material. But if you instead use what we use, what we would like to refer to as nature's carbon fiber, a stack of thin veneers out of common European spur, you have a very strong but very light material. So the taller we go, the more advantageous this material is compared to steel.
And so people generally aren't at the height that we're talking about for wind turbines. Like we're either in a building or we're in a plane. And so it's somewhere between building and plane that the wind turbines exist, and it's very windy there. And I think I've had experience where I will take the drone. I have a drone, and I'll start flying it up. And at a certain altitude, my drone is going to just start to drift away from me. And there's no way that I can tell it to come back to me. It doesn't have the speed in order to fight the wind to come back. And so I actually have to bring it down to a lower altitude where there's less wind. And that's the only way I can bring it back to me. And I've noticed that time and time again, no matter where I am, it seems that if I bring it up too far, it just starts to drift away. And that's the wind that would be powering everything. And talking about the cubes and scaling and stuff, I don't know if we mentioned that the power that you get out of the wind scales as the cube of the wind speed. So if you double the wind speed, you 8 times the power.
Wow. Oh, wow.
So that's a great effect. So when you see these smaller wind turbines, I've seen a couple in cities like Boston. There's a fairly small one. It's not much taller than many of the buildings, and it's a pretty small diameter as well. So the difference between a small wind turbine like that and a really, truly massive one like the ones that you'd be building, the difference in power generation, what would you estimate that to be?
It's massive.
Hundreds of times bigger, I would say.
Yeah.
Wow. The small ones you talk in kilowatts, and the big ones you count in megawatts.
Yeah.
So
Megawatts. Wow.
And the largest ones on the market now, mainly used for offshore, they're more than 10 megawatts. So if we can build tall enough onshore, we can use them there as well. Well, they're currently used offshore is because offshore you have less of a wind gradient, so there's less of a difference between the wind strength at different altitude. But onshore you have a wind gradient, so the taller you go, the stronger the winds, as your drone example. So that's what we want to do.
Now, I saw some footage of you installing your first test tower, and I think that's where our viewer actually went and visited. It's a small island off the coast of Sweden, right? And what are you hoping to do with that test?
That has been a project now for more than 2 years, and during this time lots of things have been tested, mostly for the tall towers, the 150-meter tall tower design for turbines more than 200 meters tall, but then we downsized the whole thing to a 1:5 scale, so you get the 30-meter tower, and we put that together using basically hand tools. This will not be the way it's done in the future. Everything will be automized, of course, but the first one, quite spectacularly, was able to make that way. And then manufacturing it, putting it together, putting it on site. And then, of course, that tower is stacked with sensors. That will be a not so dramatic test. The important tests are already done. The certification is ongoing and so forth. We've got a design basis assessment done by a notified body and so forth. So we know that it works already. This is to follow up.
Now, a lot of manufacturers seem to be slow to pick up on new technologies. They want to go with just proven, we use steel bases and that's what we're going to use. Are you guys finding it difficult to convince people in the industry that this might be a better way to go?
Before, yeah, especially when you haven't built anything, you stand anywhere you're trying to pitch this, and then it might be difficult, and you haven't learned how to pedagogically say that wood is stronger than steel. You have to learn how to do that, and but now when we've done the first installation, we find it a lot easier.
And what's the timeline look like? So, I mean, you're doing your testing now and you're in the middle of testing. When do you think you'll have your first commercial installation?
In 2 years.
Oh, wow.
Yeah. We already have a signed letter of intent for that, and it's going to transfer into a purchase agreement quite soon, hopefully. With a local utility that would like to be the pioneer.
Once the first company has signed a deal and you put up that first tower, do you think that that's going to kind of be the tipping point where other companies are more likely to start knocking on your door?
Yeah, that was what we thought. We actually thought that we would need to put up the first 30-meter tower in order to be able to sell the first large size one. But we got letters of intent for commercial-sized towers well before that, and now we got several of those. So customers are quite eager to get in on this, as it looks right now. Knock wood.
No pun intended. Now, I'm a carpenter myself. I love working with wood, and I know how strong plywood can be, especially when you're lapping the grain in opposite directions and gluing it together. But I've got to say, this sounds like a daunting task to make these huge sections. And you just said that your first ones you made by hand. Can you kind of walk us through the process of how these are built?
Yeah, so basically we get sheets of LVL, which is sort of plywood where not all the fibers are sort of every other. There is a overweight in one direction, the direction that needs to be a bit stronger. And they are then machined into the right shapes, and then they are pressed into the curved shape that these have. And then they need to be sort of machined into tolerances, yeah. So we have quite tough criteria for the tolerances to make the assembly on the site then to go smoothly.
And so are each of those panels the same? Like, are they just like Legos and you can build as tall a tower as you want? Or is it a specific, each one is kind of its own special little piece?
So first of all, the tower is conical in its shape. So the shape and the curvature changes over height. But in theory, you could possibly reuse the same parts for a different tower design. But also we have a manufacturing and design process that makes it easy to change for a different tower. So we try to make both ways possible, actually.
But basically on the same cylindrical section, you have all the modules are the same.
Yeah.
So do you need a giant crane to put this together?
Well, not. So we put the modules together into the sections close to the ground. But then, of course, to put the entire wind power plant together, then you need a giant crane, exactly, because on top of our tower, you install the turbine, and the nacelle and the generator for this weighs hundreds of tons.
Now, I have a question about the longevity of the tower. So I'm imagining with the steel tower that they're like pre-painted and that they have a certain lifespan. What's the lifespan of a wooden tower? Because I've got to imagine that it's got to be protected from the weather.
So our towers will last as long as a steel alternative, because the wind power industry works such that the customer expect a specific lifetime. And that is the lifetime that the tower is going to be specified towards, no matter the material. So if you want 25 years warranty and guarantees, you get that. If you want 35 years, you get that. It's mostly a matter of the thickness of the wall, and we fix that easily by just adding on additional layers of veneer. So it's not really a problem. And the coating of the towers is done way before assembly in the factory already. It's a polymer polyurea coating on top.
Oh, cool. Because I was picturing like a guy had to go up there with a paintbrush and like paint the whole thing. But no, it's all done on the ground.
Yeah, Geir didn't want that job, so we had to do it already in the factory.
But it can be added also that like any system that has to stay outside has to have a weatherproofing system, and they are made to protect what is inside of them. So we have a system that works for us, and the steel towers need to protect from rust, I suppose. So they have a system that works for that.
I guess the question is, has this ever been done before? Like, have we ever made tubular wooden structures like this, or has it always sort of been your typical timber construction if you wanted to make something like that?
Not that I can think of at the moment.
In old hydro plants, there are tubes, wooden tubes to lead water through, perhaps, but I haven't seen tubular structures like this anywhere. And for example, we had one of the executives from one of the largest wood manufacturer groups visit, and he said, whoa, this is unlike anything I've ever seen made out of wood before. And it's their material that we're using. So I guess not.
So, I mean, we've been inside of an old windmill before. I think it was built in like the 1800s or something. And yeah, it was not built in any way like how you've structured your wind turbine tower. So where did you come up with this idea? Like, what gave you the idea to build this out of wood as opposed to any other material? And then how did you figure out how to do it?
Well, a couple of years back, one of our co-founders, David, he had been thinking about about the wind industry for quite some time, and he has background within wood boat building, so he's familiar with the strength of this material. And the wood manufacturing industry has also been developing quite a bit. You have these very, very strong laminate materials now. And also, about 10 years ago, there was actually a German company that brought forward a wooden tower for wind power. And they built a 100-meter tall tower that is still standing in Germany. So it's a great example, but Modvion has the advantage of being a second mover here. So we could see some things that they had done that we thought could be done differently and with improvement. So we use a material that is 2.5 times stronger than what they used. And we have a much more efficient assembly process, much due to we have a self-bearing conical shaped wall whilst they had a lattice structure that they clad on with these flat modules to have their octagonal shape. So you always get inspired of what has been done before, and then you try to add on where you can.
And so because you have this modular design and you're able to build essentially a wider base than a steel structure, because again, this modularity means that you can build it almost as wide as you like. What is the limit on the height? And when you hit that limit, maybe it's limitless, I don't know, but at least where you're imagining the tallest tower that you could build in the near future to be, how much power could you generate from that wind turbine?
That's a tricky question.
Yeah. Which height would you like to?
Yeah, I think so. There are several heights that you can mention here, but I think there is a sort of, if you build a straight tower out of wood and you only consider the self weight, so to speak, I think the maximum height is around 4 kilometers. That's sort of a silly example because
that's in a perfect world, right?
Yeah, exactly. That's without any wind and with no turbine on top of that and stuff. So that's
Sure.
But that's sort of like it's not even the theoretical maximum limit, because then you still have a sort of prismatic shape, so you can sort of build a pyramid or stuff. But it's a funny sort of angle to look at it. But then we have another angle, which is where does it stop to pay off to build taller and taller wind turbines, and that's sort of where the wind gradient that we mentioned earlier stops having an effect. So when you go higher and higher up, the wind picks up because the ground sort of breaks the wind, but that effect diminishes quite a lot, and at about 300 meters it's basically no effect anymore. That in theory means that the lowest part of the rotor would be at 300 meters, and usually then the diameter of the rotor would be 300 meters as well, I think.
Yeah.
And that would mean 450 meter tower.
Yeah.
But that's very tall.
Wow.
So that would mean a total height of 600 meters, and currently they're at 240, perhaps the tallest. So
Nice.
So, I mean, the tallest wind turbine in the world could be made out of wood.
yeah, they should, and we think they will.
That's so cool.
And I mean, as you mentioned earlier, the blades right now are largely made out of balsa wood as well.
Yeah, it's a composite with balsa wood and glass fiber or carbon fiber, I think. Yeah.
I think you could do it just about either way. Yeah. But yeah, I mean, it's, when people kind of think about wind turbines, they're generally not thinking about wood because it looks so metallic. But every wind turbine that you see practically has wood in it, in the blades, the part that does arguably most of the work.
And blades, or the balsa wood, have a very high specific strength, and that's the reason to use it, and that's the reason to use wood in the towers as well.
Now, when you were just picking up that block of the cross section right there in front of you, it looked very light. Like I was trying to picture if that was a block of steel, and I think you'd have a lot of trouble picking it up. It's light, right? I mean, how much lighter is it than if you use steel?
Normally, I speak about the strength required for the tower. So for the same strength, our tower only uses about 2/3 of the weight, so it's 30% less. And for a specific volume, it's 1/16 of the weight, sort of.
Wow.
Having a wind turbine that weighs 2/3 the weight of a steel one, that means that transporting the materials to where you're going to be building it, there's going to be less effort required. So that means a lower carbon footprint. But also the manufacturing would also have a lower carbon footprint, I've got to imagine. What does that look like?
First thing you can mention is that the production of steel is very dirty, so to speak.
Carbon intense.
Yeah, carbon intense. Yeah, that's the word. And that has to do with the fact that to make iron out of iron ore, you need to get rid of the oxygen that's connected to the iron atom. And then you have a, what's it called, blast furnace, where you put in a lot of coke, which is basically coal, and you heat it up, and there's tons of carbon dioxide spitting out to produce the steel. So that's what we compete against in this world. So I think it's about 2 or 3 tons of carbon dioxide per ton of steel, while we sequester, is it 1 ton per ton of
1 ton per cubic meter.
yeah,
basically.
that's right. So 2 tons per ton of wood.
Wow. So you're almost doing the opposite. So to make steel, you need to get rid of oxygen by attaching it with carbon. And so you use hydrocarbon to take away the carbon. But then essentially what you're doing is the tree is taking in all that carbon in order to build itself. And then you're leveraging nature to create something that is going to ultimately benefit nature and humanity.
Couldn't have said it better myself.
Wow, that's a great way to put it.
Now, I was on your website and it looked like as you guys are growing that you need more employees. Is that true? Are you looking for engineers and builders?
Yeah, that is true. Modvion will grow for numbers of years, hopefully. So we're currently still quite a small team, and we have to take in new employees at the time that we can manage. But definitely the team will grow.
So, I mean, if you're watching this right now and you might be interested in joining this growing industry, go check out Modvion's website. And for those who are watching, we get lots of emails all the time about just, startup companies, and they're always asking me, Zach, what's the next company to invest in? Are you a publicly traded company? How could people get involved in your company?
We're not publicly traded. Previous rounds have been taken care of to a large extent by business angels, but it's that kind of investment.
Okay, so basically keep your eye on this company, and who knows where you guys will go in the future in terms of funding rounds and so forth. But I assume that eventually, if things work out, you're going to need more capital as you build out, bigger and bigger factories and so forth. Now, they must be fun factories to work in, I can imagine. Like, as a woodworker myself, I love being in wood shops, and this just sounds like you're going to be building giant wood shops.
Yeah, kind of. The production of the prototype tower was a lot of work by hand with the tools of the trade, so to speak. It was a lot of fun. It was hard work for a long time, but it's a lot of fun to work with the material, which is an additional benefit.
And can you just talk about your intellectual property? So basically, I mean, if Jesse and I wanted to go out and build this tomorrow, you guys, I believe, own the intellectual property to this idea.
Yeah, so we have patents on several parts of the of how to do this, basically on the joints and so forth, and also on the what we see as the most efficient way to build a wooden tower for wind turbines, basically. But if you want to build it for yourself, that's okay, as long as you don't sell it.
Don't give Jesse any ideas.
I mean, I'm just, it sounds like a lot of thinking went into your actual design. And if I tomorrow wanted to do it, it sounds like it'd be a whole lot of work. And I'm so glad that you guys are actually doing that work, because it's going to be such a benefit to everyone if we can have larger and more efficient wind turbines that can be running more frequently.
And then lastly, if people are watching right now from around the world, maybe in the United States, and they're hearing like, wait, we could build taller towers, can they reach out to you? Are you available to build towers, say, here in America?
Yeah, definitely. Modvion aims to be a global company in the future. We start off here in Northern Europe, but of course we would like to go to America.
And very last question, have you been on top of a wind turbine, and are you afraid of heights?
Yes and no on the two questions.
Wow.
The
Great guy for the job. Yeah.
Geir used to be a master climber, so he's not afraid of things like that. I feel the taller you go, when you're above a certain altitude, you don't really feel like you're going to hit the ground anymore.
If you just jump off to the side fast enough, you'll just go into orbit, right?
Yeah, haven't you ever felt that when it's more scary to bungee jump than to have a para jump. So that's my take on it.
Awesome. Well, thank you so much for joining us today and answering all of our questions. I'm really excited about wind turbines now, especially wood ones.
Yeah.
I mean, It's so nice to know that there are more earth-friendly ways of making earth-friendly technology. And I want to thank you for all your hard work and everything that you do, because it gives us a little bit more hope in the world. So thank you.
Thank you. We should have hope, and thank you for telling our story.